Okay, folks, today we're going to look at some ideas of factoring when a equals 2 is not equal to 1. Now to start with, I want to talk about the standard form of a quadratic equation. This is f of x equals ax squared plus bx plus c. Okay, where a, b, and c, they're generally integers, but they are going to be constants. Okay, so we have worked with a before, and this becomes probably the leading coefficient, it's often known as. Okay, so we have a few different ways we can deal with it. If a is equal to 1, we can use one-step diamond, this kind of thing. X squared plus 5x, and I could say minus 6. When that happens, you can usually go, I still like to say, okay, 1 times negative 6 goes to the top of the diamond. The middle number goes to the bottom. Now the factors of negative 6 that add to 5, we see 2 and 3 would be adding, but because they're subtracting, I think we would go with negative 6 and positive 1. No, it's going to be positive 6 and negative 1. In this case, it should factor out to this. We would have most things will factor in this style with 2 empty parentheses. I know I have x and x, and then this plus 6 will go here, and the minus 1 will go here. Okay? And that's how we'll factor the one-step diamond. I want to check this to be sure we get the correct thing. X times x is x squared. X times negative 1 is minus 1x. The inside plus 6x. The last minus 6. When you combine those, we should then get x squared plus 5x minus 6, which is the same as what we started with here. Okay? Now, if a is not equal to 1, let's say 2, 3, or some other number, we have at least 2 steps. One approach is diamond plus box. The other one is a diamond plus split fraction. And we can also, and the old school way of doing that is guess and check, also known as reverse FOIL. And I'll focus mostly on the other 2 methods. Okay, now the diamond plus box. Let's say I've got something along the line of this. 2x squared minus 5x. Okay, and then I'll go ahead and say minus 12. Okay, so our first step on this is to go ahead and multiply a times c. That's going to be 2x squared times negative 12. That goes at the top of the diamond, so negative 24x squared. The middle term, the negative 5, will go directly down here, negative 5x. So now I'm going to find 2 factors of 24 that subtract to 5. Let's see, 6 times 4 won't work because that's 2. Let's see, how about 8 times 3? Oh, 8 times 3 will work. Let's try that. 8x and 3x. And it looks like to get to a negative 5, it should be a negative 8x. Okay? And our second step is to go ahead and do what we call the box. Okay? And what the box is, it's a nice little system. That's going to look like this. Now, in this first section is going to go the first term, the leading term. In this case, it'll be 2x squared. In this box, it'll be the last term, generally the constant. In this case, it's minus 12. Now, as far as the other 2 positions, I have a negative 8x and I have a positive 3x. They can go in either one of the 2 boxes. I'll put the negative 8x here and the positive 3x here. So, and it could go in either order. Now I'm going to look for greatest common factor between these. Now when I have 2x and 3x, 2x squared and 3x, the only common factor in this case is x. Once I have that first position, now we just divide. 2x squared divided by x will be 2x, and I put it right above. 3x divided by x will be 3. Negative 8x divided by 2 will be minus 4. This last one should work out. Negative 12 divided by 3 is also negative 4. So now I convert these into a binomials. One of them will be 2x, and since there's no sign, is an understood plus, and the other one is x minus 4. Let's FOIL to check that out to see if it works. The first, 2x times x, is 2x squared. The outside, 2x times negative 4, is minus 8x. The inside, 3 times x plus 3x. And the last, 3 times negative 4, is minus 12. I combine these two middle terms. I get 2x squared minus 5x minus 12, which is exactly what I started with. Done. Okay, for this next example, let's try something with a little more challenging, and I'm going to talk about how to do the diamond and split fractions. So for this one, I'll start out with 6x squared plus 7x minus 54. So I've got some large numbers we're working with. So our first step, of course, is 6x times negative 54 to go to the top of the diamond. Okay, 6 times 50 is 300. 6 times 4 is 24, so I got negative 324. And down here I have 7x. Okay, now this is going to be a little bit challenging, so I might have to go to a calculator to help me with this. I just have a little calculator on here. I can try out a few things and see how to get to negative 324. Okay, so let me try dividing 324 by a few things. What if I divide it by 4? I get 81. I got to go bigger. Now 81 goes into 9. How about 324 divided by 9? I get 36. All right, getting closer. Let me try 18. 324 divided by 18. It's 18 times 18, so that's not going to work. How about 324 divided by 16? I don't get a whole number. 324 divided by 12. 12 and 27. I'm getting closer. Okay, I'm back. I made a crazy mistake here because in reality, I did not multiply correctly. Okay, and this number instead of 54 is supposed to be 63. Okay, and then that'll tell us that 6 times 63 is negative 378. Now, as I try some things to multiply with that, if I look at 378 going to 7, 378 divided by 24 doesn't work nicely. 378 divided by, let's say, 20, 18, that's too far. 378 divided by, let's say, 18, 21. There's 3 apart. I'm getting closer, but 21 is a multiple of 7, and 14 is a multiple. Let me try 14. 378 divided by 14. That gives me 27. And 27 minus 14 is perfect. So what I have here is 27, and I have 14, and it has to be a negative 14. Okay? Now this one's rather messy. So for the split fraction, what you do is you make a little incision here and put a 6x here, which comes from the first term. Do the same thing on the opposite side, 6x. Then you replace the lower part with that each of our two terms, 27 on one of them and negative 14 on the other. Now we need to do is reduce the fraction. I know I can divide by 3 to get 2 here, divide 27 by 3 to get 9. So this gives me the factor 2x plus 9. Now 6 and 14 don't go into each other, but they're both even numbers, so I can divide both of those by 2. So that's going to give me the factor 3x minus 7. And that's going to give us that split fraction approach. Here's our answer. I'll double check the inside and outside. 9 times 3 is 27x. Negative 7 times 2 is minus 14x. 27 minus 14 will indeed give me positive 7. Now, I won't get into the guess and check. Let me show you a couple other types. There is a special type known as difference of squares. Now, with difference of squares, it only has 2 terms usually. And what that'll look like might be something along the line of this. X squared minus 36. Now there's no b term, what's known as the linear term. 1 is our quadratic term, c is our constant term. Now I could try this like this. I know they multiply to 36, but since there's no middle term, I'm going to put a 0 down here. And that might help us see this a little better. Now 36, let's see, 9 times 4, 12 times 3. What about 6 times 6? Won't that work? How about 6 times negative 6? 6 plus negative 6 gives you 0. So this one would simply be x plus 6 times x minus 6. Now if we start recognizing it, let's try another one. X squared minus 49. Now, I think that this is going to be the factors of negative 49 that add to 0, 7 and negative 7. So it's x plus 7 times x minus 7. Now we start recognizing a little bit better. Let's try another one. This time, let's try 4x squared minus, let's go with 9y squared. Now this is a little more challenging. If I was to try to do this, I know I have a middle term and I also have some other problems, but I am starting to see that if I go back to this one, the square root of x squared is x. The square root of 49 is 7. So let me try square rooting this. The square root of 4x is 2x. The square root of 9y is 3y. So if I follow the other pattern, it would be 2x plus 3y times 2x minus 3y. These are known as conjugates because the middle term gets canceled out. I'm going to do one last quick one, and this is where we have a GCF built in. What if I have this 3x cubed, 3x to the third power, okay, minus 6x squared, and if I go ahead and say plus 3x. Now the first thing you should check for most of the time is look for the GCF. The second thing is we want to see if we can do the diamond or the binomials. So I see I have 3 that can divide out of all 3 of these. I also notice I have x to the 1 power, 2 power, 3 power, so greatest common factor is actually 3x. So my first factoring is 3x times x squared minus 2x. Now 3x divided by 3x, there's some confusion with that. That's the same number, it's not 0, it's going to be 1. Now that I have a trinomial, I want to see if I can get this factored. So I'm going to try this in my diamond. So 1 times 1 is 1 to negative 2. I believe I can multiply to 1 to get to negative 2. 1 times 1 will give me 1, and 1 plus 1 is 2, but I have to make both of these negative. So now what I have here is x minus 1 times x minus 1, and I'll put the 3x back here, and the final answer would look like this. Because both of these are the same, we should call it x minus 1 quantity squared. Thank you.